This is the fourth algorithm, inverse DIT FFT algorithm. This will be similar to your DIF FFT algorithm. In DIF, we'll make first 8, 4 and 2. So similarly here also first we have to, the structure will be 8 point, 4 point and then 2 point. So the difference is here is input will be, we have to take it as a frequency domain sequence. That is a capital X of k we have to take. So it will be in a normal order, so x of 0 to x of 7. So output will be in a bit reversed order, but it will be, because since it is a inverse, so we'll get the output will be a time domain sequence, that is x of 0 to x of 7 will get, but it will be in a bit reversed order. But remaining structure everything will be same, but here we have to use a twiddle factor as a negative value we have to use here. So here the given sequence they given, it is x of k equal to the sequence they have given. So as it is, you can write here, it is x of 0 to it is x of 7 all the value. But if you want to find out the first value, the first value will be here, the straight line is coming here and this is joining with this line, that is x of 0 adding with x of 4, that is 7 plus 1, here it will be a 8. So similarly if you are coming to this point, so here it will be, the line is coming as it is a 7 and here x of 4 is 1, the 1 is multiplied with it is minus 1. So here it is 7 minus 1, it is 6, the 6 will be multiplied with your twiddle factor. So that means here the answer it is w8 to the power minus 0 value is 1. So here it is 6. So similarly we have to find out all the value, that value will be input to the next stage. So here if you are coming to this point, again here this value if you want to find out, so the straight line here the values it is a 8 and here this line is it is 0, correct, the values it is 0. So 8 plus 0 is here it is 8. If you are coming to this one, so here the line is coming here it is a 8 and here it is 0. So 0 into minus 1 is 0. After adding 8 plus minus 0 it is 8 into multiplied with w4 to the power of minus 0, value will be 1, so it is a 8. So similarly we have to find out the second stage and we have to find out the final stage. After finding the final stage, you have to multiply, you have to divide by 1 by 8. So whatever value you are getting, that value will be divided by 1 by 8. That will gives the final value, that will be in a bit reversed order, that is your time domain sequence. So this is the inverse DIT FFT algorithm. So till now whatever problem we have done, it is for 8 point DFT. So now one problem will do with 4 point. So compute the DFT of the sequence for x of n equal to cos n pi by 2 where capital N equal to 4 using DIT FFT algorithm. So they mentioned here you have to use a DIT FFT algorithm. Since it is a 4 point, so draw only the 4 line and you have to make a 2 point and 4 point. So here input will be, we know that DIT FFT algorithm input will be, it is in a bit reversed order and output will be in a normal order. So output will be a frequency domain sequence, input will be a time domain sequence. So here the sequence they given us x of n equal to, it is cos n pi by 2. If you are substituting n value as a 0, n value as a 1, n value as a 2, n value as a 3, will get what is where x of 0 to x of 3, all the value will get. So we have to write here it is in a bit reversed order. Then we'll find out what is the first stage. After finding the first stage, that will be input to the next stage. So here we can find out the output. The output will be in a, it is in a normal order, that is a frequency domain sequence. So you're getting 0 to 0 to. Similarly if they're asking for DAF, so first you have to draw a 4 point, then you have to draw a 2 point, then we have to find out what is the input will be, it is in a normal order, output will be in a bit reversed order will get. So similarly we can use any algorithm and we can find out here. This is the n equal to 4 point DFT. So the third method is we can do by the convolution also. So in the first unit only we are seeing the circular convolution can be done by 4 ways. One is the circular array, tabular array, matrix method and Stockham's method, correct? So here what we are using is, we are using the Stockham's method. We know, just for remembering I'm telling, Stockham's method is first we have to find out if they are giving the 2 sequence. So we have to find out the DFT for the first sequence separately and DFT for the second sequence separately, and then you have to make the product of x1 of k multiplied with x2 of k, that we can take it as a x3 of k. So that x3 of k we have to take the inverse, so that will gives your output of the sequence. So same thing only here DFT, instead of here what we are doing is the DFT can be find out by here it is a FFT algorithm. So we have to find out what is x1 of k, that is x1 of 0 to x1 of 3, and again x2 of 0 to x2 of 3. Then we have to make the product of this two. For this sequence you have to take the inverse. So we'll get what is your output sequence here. So we'll see here the sequence they given it as x1 of n, they given this value, x2 of n they given, but they have given the condition that x1 of n we have to use by DIT FFT algorithm and x2 of n by DIF FFT algorithm. If they are not mentioning, you can use any one of the algorithm and you can do, and using the above results evaluate the circular convolution of x1 of n and x2 of n. So circular convolution is nothing but it is a product of this two. X1 of n is convolute with x2 of n. So here we'll see the first one. According to the first sequences, here it is 1, 1 by 2, 1 by 4, 1 by 8. If you are it is using DIT. So DIT means first you have to make a 2 point and you have to make a 4 point. Correct? So here input will be a bit reversed order. It is a time domain sequence, and output will be a frequency domain sequence. It will be in a normal order. You know how to calculate. So first thing you have to calculate the first stage, that will be input to the next stage. So we'll get a final value what is x1 of 0 to x1 of 3. So this is by using DIT FFT algorithm. So second one is they have given the second sequence x2 of n. We have to do it by DIF FFT algorithm. So DIF means we know the structure will be 4 point, then it will come 2 point. So here input will be a normal order, output will be a bit reversed order. So again we can find first stage and second stage. So we'll get that is x2 of 0 to x2 of 3. Correct? So here it will be a bit reversed order. While multiplying x1 of 0 is multiplied with x2 of 0, x1 of 1 will be multiplied with x2 of 1, and x1 of 2 is multiplied with x2 of 2, and x1 of 3 is multiplied with x3 of 3. So after making the product of this two, for the product sequence, so we have to take the inverse. So we'll get the resultant sequence. So here we have multiplied both the sequence x1 of k, x2 of k. So that will be input to the input here. So here I used a inverse DIT. If you want, you can use inverse DIF also. So here I have used inverse DIT. So it will be again it is similar to your DIF. So it is a 4 point, again 2 point, but total factors will come negative, and again it is a inverse. So we have to divide with, after the final resultant value you have to divide by, it is a 1 by 4. So we'll get the sequence will be, it is in a normal order we'll get. Here we'll get it is in a, the output will be, input will be in a, it is a bit reversed order. If we are using here DIF, we have to draw 2 point, 4 point. So here the resultant value will be in bit reversed order. We can write it in a normal way. If you are writing, both the answer will be same. So you can use any one of the method we can use. So this is important. This is we are doing in lab also. So sometimes they will ask like this problem also. So you can refer how to do the circular convolution.